Hello, it's Scott Manley here with a bit of a tutorial on aircraft design. Now, aircraft are actually vastly more complicated than spacecraft for many reasons, but I'm going to use this very simple test bed. We have a standard capsule, we have a little girder on here that's going to serve as a landing skid, and we have some of these sepatrons to basically get it up to speed, and we're going to explore aerodynamics. Also, in the action groups, we have the ability to deactivate the internal torque of this. But to start out with, we're going to just put basic wings on this, and I'm going to talk a little about how this flies. So we're going to use extra large wings, and I'm going to stick these extra large wings on, obviously symmetrical, and it kind of looks like I don't know, some crazy... Actually, let's put these ones on. Let's make it look like an A-wing fighter, huh? There we go. So it's like a Jedi starfighter or something. That looks pretty good. Now, since I don't really have landing gear or anything, I'm just going to make this thing launch vertically, and then we'll watch what happens. Okay, and we just hit space and we take off. And immediately we take off into the ground. Why did that happen? Let's revert to launch and try that again. This time I'm going to press T to enable stability control. So, stability, go. And actually, we fly more or less straight. But as soon as I turn, whoa, the thing just pushes very quickly in one direction or the other. In fact, I have to push quite hard to get it to turn. And the reason is it wants to push itself away from that velocity vector. What we've got here is an unstable aircraft. And the reason for this is the center of lift is well in front of the center of mass. And so because of that, this aircraft will want to turn, and in fact, in this case, it's now going to go backwards and kill me. This is a common mistake that people make, is they build aircraft which have their center of mass in the wrong place. In fact, that's the most important thing, really. Let's actually take a look at how this lays out when I put it straight, right? So we'll put this down, and we'll use these two icons here. These are critical. Look at that. That is the center of lift. That is the center of mass. Now, consider what happens, right? As you're flying into the wind, right? And if I just raise the nose a little, right? Now, what happens is the air pressure is basically coming from the front, and it is applying a force to that blue ball. And that will actually tend to push it around the center of mass and increase the angle of attack. And with the increased angle of attack, that means the force gets greater. What you have is an unstable situation. As it moves further and further around, the force gets greater, and therefore you tend to spin out more and more. And of course, the solution to this is to move the blue center of lift indicator behind the center of mass, so that when the force is applied, it tends to push it back to the center. With these wings, that's about as far back as it'll go, but this should actually work. So let's try putting this vertical and seeing how this works. Okay, so this should be a little more stable, and here we go. There, look, this is more or less holding stable as I'm turning it. Now, I don't want to turn it too hard because the center of mass is pretty closely in line with the body of the aircraft. Now, the one thing to realize is that the thing that's steering us is actually aircraft, the control capsule torque. And if we... yes, oh dear. Okay, yes, that didn't work too well. The thing that was controlling us was the aircraft, was the torque from the capsule. And really, you want to be flying it using control surfaces. So for all tests from this point on, we're going to disable the torque from the capsule, right? So first thing, I'm going to take these and we're going to add some little control surfaces to it. Now, control surfaces, they almost always want to attach in some way that isn't correct. You need to rotate them using the QWASD. To make them actually in the correct position. So this should help a little. Let's see what happens there. And of course, point this back at the sky. Okay, so I'm going to pretty much press 1 and space at the same time to fire my stage and disable anything but the flaps, right? So if I right click on this, it says reaction wheels disabled. I'm going to take this thing over. And the aircraft will more or less fly according to my commands. It wants to go a little low. I have to really kind of fight it because it wants to go down. but it does actually want to fly relatively nicely. Now, the only problem with this is if I want to turn, right, then as you see, as I start to turn, my velocity vector tends to drop down. What's happening is I'm drifting sideways, and without any torque in the capsule, there's really no way for me to correct this. And, well, okay, I crash in the end again. But that's fine, because this is all about testing. So, to avoid the nose dropping like that, or the velocity dropping without the nose dropping, we of course need to add a tail plane. And you can just add a dumb tail fin. Let's just stick this on here. Actually, let's push this down and add a dumb tail fin, like right here. There, that, if you look at it, should be, well, center of mass is there, center of this thing is there. This should actually help us keep a little more straight. So let's launch this and find out. So yeah, we're only not going to use any capsule torque. We're only using vertical. We're only using stabilizers here, and this vertical thing is essentially a vertical stabilizer. It's passive, but as it turns, you see it keeps the velocity vector more or less up. So I now actually have a somewhat flyable aircraft using just these very simple parts. And again, I remind you, yeah, reaction wheels disabled. This thing is flying. And actually, you can land this thing, and of course, easiest way to land it is to use the stability control system and more or less just have it hold the nose high and slow down very slowly and keep bleeding, getting higher and higher, bleeding your velocity up, and yeah, there you go, perfect landing. So that is entirely aerodynamics that's working there. So there we've got, we need a vertical stabilizer. You can put a control surface on that if you want. You need definitely vertical control surfaces and wings, and the wings need to be, everything needs to be behind the center of mass. So that's the basics for building an aircraft which is controllable. Now, there's more things to learn about this. Let's switch this down, and I'm going to put slightly bigger wings on this now at this point, and we're going to put we're going to put completely different wings on this. So under aerodynamics, let's put a delta wing on here, and I'm going to put the delta wing as far back as it will let me. And again, you got to do these things symmetrically, in case you hadn't guessed. Symmetric is the only way to go, and by putting that on by default, yeah, it's slightly in front, but if we put on the standard control surface here, and got to find the right buttons. There, okay, so we got those on there. You see that these have shifted the thing backwards, shifted the center of lift backwards. And the other thing I want to do now is, of course, I'm going to use this Delta Deluxe winglet as my control surface. Now, we'll stick this here. There, so that actually has a little flap built in. Now, okay, that's all well and good. That looks like what we had already. But what I'm going to do is re-grab these things, shift them as far back as I can, and using Shift and Q, or Shift and E, I'm going to give these like a 15-degree vertical angle here, right? So this, you know, it's called a dihedral wing design here. And this is supposed to contribute to stability. Okay, so again, immediately one and space, and we fly. Okay. So again, reaction wheels disabled. Now I'm going to turn a little, right? Just roll myself over. And watch what happens. As I am just pulling upwards, the thing more or less levels itself out automatically. Look down in the bottom left at the control inputs, right? So I start to turn. I am not rolling. It is just doing that on its own, right? As soon as I turn, it wants to level itself out. And this is basically these wings that arch upwards. This is a stability enhancing feature. It makes the aircraft easier to control by basically wanting it to restore its attitude to a vertical, attitude, more or less. So it becomes much easier to fly these things. Now, let's, of course, see what happens if I do it the other way. So, yes, again, we'll grab these wings and we'll give them a 15 degrees negative. And it'll be... wait a second. Yeah, there. Okay. Yeah, it'll be a little like, I don't know, a high-tech space fighter. You remember the Vipers from Battlestar Galactica? They had those stubby little wings like that. They kind of, you know, they were mostly designed for flying in space. But I mean, given that the wings were so far back, they would have been stable in an atmosphere. They just wouldn't have provided much lift. And, okay, I made a slight error here. Let's see if I can get into the air. No. Okay, so fire the engines and off we go. Now, we are flying this nicely, and if I turn a little now, well, watch again. I'll just give it a slight turn, right? And I'll just more or less keep the nose up. And as you can see, as you expected from my lead up to this, the aircraft is wanting to bank more and more as I turn this. So this is a property that may be desirable in some aircraft designs, but probably not in anything you're going to be flying. So this is called an anhedral design, and obviously in this case it has all sorts of disadvantages, especially since it makes landing it surprisingly hard because your wings are going to hit the ground before your capsule. Oh, here, let's go hit something. Whoa! A lot of fun to be had. Okay, so that's part one. We've essentially discussed aerodynamic stability, configurations of wings. The principles are you want to put your wings on, you want to look at where the center of lift is, and you want to make sure that the center of lift is slightly behind the center of mass. Always. If it ever moves in front of the center of mass, you're going to have trouble controlling your vehicle. You want to make sure you have vertical stabilizers. It helps if they have control surfaces, but it's not absolutely essential. Wings tilting upwards will tend to make your aircraft more stable. Having the tilt downwards will tend to make it less stable, which may or may not be what you want. Now in future parts we're going to look at adding the engines, adding the landing gear, and of course making the whole thing lift off without exploding all over the runway. But that's in future episodes.